Welcome to Sigest, your fortnightly serving of digestible science from plant and food research.
Kia ora koutou and welcome to Sigest. Well, anyone who's owned a pet goldfish will tell you feeding a fish ain't easy. Too much food and they die, too little food and they die, feed them yesterday's pizza and they also die. Turns out fish are pretty picky eaters. Today I'll be talking with food technologist and aquafeeds expert Katrina Fletcher about the challenges of supplying food to our $600 million aquaculture industry. Kia ora, Katrina, and welcome to Sigest.
Hi there, Andrew.
Before we take a deep dive into the fish farm, I'd like you to do just a short bio of yourself, because you come from an interesting background. You were a food technologist with a background in infant formulas. So how did you end up in fish food?
I started my career with Fonterra Research and Development Centre in the development of protein ingredients for sports nutrition and moved into infant formula. Also had the pleasure of developing specialty lipid ingredients from dairy. And so when I came across to plant and food research, I leveraged all that expertise in ingredient process and product development into food ingredients. And surprisingly, there's a lot of knowledge you can transfer from human nutrition through to fish nutrition. So Damien and his expert team down in Nelson saw a gap in the development of aquafeeds for their fish and asked us to join the team. So I'm part of a growing futures program. It's called Aquafeeds for Open Ocean Aquaculture, and it's looking to develop New Zealand aquafeeds for New Zealand fish.
So strange synergies between fussy toddlers and fussy fish.
That's right.
Yeah.
Yeah.
Okay, let's start with the big picture first. Okay, so aquaculture, most people have heard of fish farming and aquaculture, and it's the fastest growing food production system in the world at the moment. So could you tell us a little bit about the current situation and what are the main species being farmed globally around the world in these fish farms?
Surprisingly, the main fish species that are farmed globally are carp, but they are generally fed on very low-cost feeds. So in the context of today's talk, we're talking about specialty aquafeeds for salmonids and for trout, sea bass, sea bream, those species that have very high protein and lipid requirements in their diets, fish species that can't generate their own omega-3 fatty acids. So we have to provide those in the diet so that we get those into our diet as well. That's currently where the state of the aquafeeds industry is that they can't produce any more fish meal or fish oil to put into these specialty aquafeeds. So in order for the aquaculture industry to grow, we need to find alternative ingredients to fish.
Okay. And in New Zealand, most people have heard of the farm salmon. Is that the main farm species in New Zealand?
Yeah, our fish farming industry is just ripe for growth. At the moment, we only farm Chinook salmon. We're only one of 2 countries in the world that farm Chinook salmon, with Canada being the other one, key producer. And Chinook salmon, although it's a premium salmon, it's only about 0.5% of the total farmed salmon in the world, which is Atlantic salmon. So we have a huge opportunity to grow our volumes from less than about 15,000 tonnes of salmon to well over 100,000 tonnes, not just of Chinook salmon, but also of our native fish species that are very attractive to Asian countries such as snapper, trevally, and kingfish.
Okay. And in New Zealand, what are they currently being fed? Is it pellets? And what are the pellets actually made of?
When we're talking about aquafeeds for juveniles through to adults and broodstock, we're talking about feeding them pelleted aquafeeds that are imported largely from Australia.
Within that pelleted component, I guess there's a whole lot of different things, right? So could you break it down a little bit and tell us what's the average composition of, say, a salmon pellet that they feed on the salmon farms?
So at the moment, your salmon pellets might have 15 to 20% fish meal. They might have anywhere around 5 to 10% fish oil. They'll contain a huge proportion of soybean meal or another cereal seed meal, or corn byproducts such as corn gluten feed. They also have to contain a certain amount of starch so that when they're produced, they form the right textures, densities, and they hold together really well because salmon will not eat feed fine. So they have to maintain their integrity when they're fed out to the pens.
When we talked yesterday, there was some interesting things you said about the structure of it. For some fish, I think you mentioned that the pellet has to have a shape to it so the fish can determine which is the head and which is the tail. So there's a bit of, it's not just what's in it, is it? It's also that the structure and the shape of the pellet is important.
That's right. All fish prefer a texture and a softness that's closer to the forage fish that they eat in the wild. And some species like the bluefin tuna, they get very confused when the pellets are symmetrical and don't have an obvious head or a tail. Thankfully, our Chinook salmon aren't quite so fussy, or our other species. But the challenges are to make sure that when our fish are farmed, they grow healthily using the least amount of feed for a certain amount of tissue. That's called a food conversion ratio. And that they can grow fast within a commercially viable time frame, and that they can adapt to the changing environment around them. So at the moment, with temperatures rising, that has a potential impact on the amount that fish feed, which will impact their growth negatively.
So they feed less at a higher water temperature generally?
They do, yeah. They have a temperature zone where they feed really well. So at the moment, in our Nelson Finfish facility, we can only do trials 6 months of the year during the warmer months, and they will stop eating when the temperature gets too cold or too hot. So one of our challenges is to encourage them to feed for longer periods during the year to maintain their growth. One way to do that is to make the feeds more palatable to them and easier to digest.
Within the pellet, there's a fish component. I think you mentioned about 15% is fish meal. Why do then fish need to eat fish?
We mentioned before that a lot of the fish that we eat can't produce their own omega-3 fatty acids, particularly EPA and DHA, so it has to be provided in the diet, and traditionally that's come from forage fish. So there's a huge amount of forage fish meal made globally that is imported around the world to different producers. And so there's also a big incentive to provide alternatives to that, specifically salmonids, where we expect to get a lot of the omega-3s in our diet. Their aquafeed can contain over 30% lipid, and a lot of that has to come from fish oil at the moment. But now there's some really good science being done to find alternative sources of omega-3 fatty acids, such as genetically modified canola oil, which we're not going to use in Australasia, and algal oils that are grown that have very high levels of these omega-3s in them. Also, the amino acid profile of the fish meal is adapted for the species that we're trying to farm. And so it's important when we replace fish meal with other protein sources that protein quality is the same, or if not better, than that provided by fish meal.
Right. So in terms of substituting it for a plant-based thing, it's not a simple measure of just putting equal mass or equal volume of carbohydrate or something like that. And it's quite complex, and what the amino acid composition is really important.
That's right. Just like us, there are amino acids that fish can't produce, and they have to be provided in the diet. They're called essential amino acids, and the fish essential amino acids are basically the same as those for humans. And so when we look at developing alternative ingredients, we want those that have essential amino acid profiles that are at least as good as those in fish meal. And that comes not only from the natural source, whether it be a forage protein ingredient or whether it be a fish meal ingredient that you've produced from fish trimmings or anything else like that. You have to also process it so that you don't damage the protein quality as well.
The tricky business, isn't it? In terms of the aquafeeds at the moment we're using in New Zealand, are they all imported?
We do not have an aquafeed mill in New Zealand, so all of our farmed fish in New Zealand are fed on imported feed, and that's something we'd really like to change. We have a wealth of bioresources that we can use. We are built on primary industries that generate horticultural and agricultural wastes that could either be directly or indirectly used in feeds for New Zealand fish.
Yeah, and this probably brings us quite nicely to our next question, which is really outlining some of the problems with the current situation, because there are some big issues, probably some people are aware of, with the aquafeeds industry, and maybe we could touch on what some of those big issues are at the moment. So the fish component we could start with.
Well, the fish component, if we were going to develop an aquafeed industry in New Zealand, we do need fish meal. We currently export all our fish meal, which is unfortunate. And of course, with aquafeeds, they're the biggest carbon footprint in the aquaculture supply chain, the ingredients themselves. And so being able to produce local aquafeeds from local feed ingredients is really going to have a positive impact on minimising our carbon footprint. If we could grow the number of species that we farm in New Zealand, we're going to improve our resilience, we're going to improve the diversity of our offerings, and we're also going to enable internal use of fish meal, because you can't feed salmon fish meal to salmon. But if we produce 2 or 3 species of fish in New Zealand, then we can perhaps feed kingfish fish meal to salmon, and we can produce that fish meal from all the fish trimmings and waste that we can't eat as humans. So that's really about total utilisation. And then we move to alternative protein ingredients. We grow forage really, really well in New Zealand, and our forages are high in protein compared with overseas forage species that are the same, like our alfalfa and our ryegrass. If we can produce forage protein ingredients that can be used in aquafeeds, we can diversify our land use and minimise our carbon footprint in that way too.
Yeah, because to get back to some of the ingredients in the fish feed, like what I read was there are literally millions of tons of forage fish ground up and turned to fish meal every year. And these are fish which can be directly eaten and utilized by humans. So we're losing massive biomass to feed food, basically, to feed fish. And that's a major challenge to the situation at the moment, right?
Yeah, no, that's absolutely right. Some of the forage fish species that are produced into fish meal could be eaten by humans, and the reality is the world can't actually catch any more forage fish than they currently do. Those quotas have been static since 1995, and there's increasing demand for that volume to be pushed into human food. And so that just provides more impetus for us to move to these lower grade fish meals produced from fish waste or fish trimmings, and to find alternative protein sources. And one we haven't tapped on is the insect meal industry, which is growing rapidly over in Europe and is a real potential new industry for New Zealand as well.
Because even, I think, soy protein is controversial, because to grow soy often involves deforestation and stuff, doesn't it? So even feeding imported soy protein to fish, which sounds good, sounds better than using fish, it actually has problems too, right?
Yeah, absolutely. There's just been studies to show that the importation of soybean meal around the world is one of the biggest contributors in terms of carbon impact in the aquafeed supply chain. And we as New Zealanders would love to be able to replace soybean meal with a New Zealand protein ingredient with a much lower carbon footprint, not just for aquafeeds, but also our poultry feeds, our pig feeds, and our general feed industry in New Zealand. They're all wanting an alternative to soybean meal products.
Yeah, just to improve the environmental credentials of the industry. I guess it's nice to have those stamps and labels on your product. Okay, so you've already mentioned we're really good at growing grass and forage crops in New Zealand. What are some of the crops that have been looked at the moment that could potentially be used as fish food?
Well, in our Growing Futures program that we alluded to for aquafeeds for open ocean aquaculture, we've settled on 2 crops that we're investigating, and they are lucerne and perennial ryegrass. And these potential crops are grown widely throughout New Zealand, often for growing cattle. So we're really excited in that we not only know how to grow them really well, but they're current crops for animals. And so it opens up rotational grazing opportunities, reducing the dairy farming on areas that can't sustain the levels of dairy farming at current practices, and being able to generate alternative sources of incomes for those farmers.
So we've already got a bit of a head start because it's already been used as a feed source for cattle and stuff like that.
Yeah, and we have fantastic breeding programs. We've got alfalfa that can contain over 30% dry basis protein. So we're starting with an advantage when you consider that a lot of the forage crops comprise fibre and starch that fish don't want but can be used in other applications.
Yeah, which kind of segues quite well to my next question, was that can we use all the components of a plant-based diet, or will we just be creating another waste stream we have to get rid of?
Totally. Given that forages contain a lot of fibre and starch, we absolutely have to find higher value returns on all of the components. So some of the things that we might be looking at is using some of those waste streams to grow insects. They have a very low footprint, insect rearing facilities, and they have the ability to convert carbohydrate to protein and lipid. And we know that lots of fish species love insects. And so producing insect meal and insect oils as alternatives to the fish meal or other fish ingredients that we use is a really exciting prospect and a way to get total utilisation of their forage crop in a profitable way.
Yeah, that sounds like it's got real potential because, as you said, it's got a composition which is pretty similar to what a fish likes in terms of its lipid and proteins. So are we looking at specific insects already, or is it still at the sort of planning stage?
Yes, no, absolutely. One of the research aims in the aquafeeds program is to investigate what New Zealand insect species might be able to be used and reared in New Zealand for New Zealand fish species. And that's really exciting because we can potentially tailor the nutritional profile of those insects to the nutritional requirements of our species and provide something that's quite unique globally. At the same time, in that same research aim, we're investigating the growth of black soldier fly larval meal for use in New Zealand species. It has a lot of advantages, the black soldier fly, in that can convert a huge number of different organic waste streams and grow on them and produce not only a lot of high quality insect meals, but also a high quality frass. So frass is the generic term you use for all the leftover feed, contaminated basically with the insect poo. And it's a very high nitrogen fertiliser, so it has potential to at least partially substitute the synthetic nitrogen fertilisers that we currently use.
That's really cool because you can see the potential for like a closed system where your insects are feeding the fish, generating a fertilizer to fertilize a forage crop, which you can also feed into your fish farm. So yeah, that's pretty exciting.
Yeah, that is really exciting.
So there seems to be a big shift in the way aquaculture is going at the moment because we've been hearing a lot about the impact that coastal fish farming has on our coastlines in terms of the pollution and stuff generated from that. So there's a move towards open aquaculture. That's a bit of a mouthful. Could you firstly define what is open ocean aquaculture?
Yeah. Okay. So basically, and this is not my area of expertise, but in lay terms, it's about moving out our fish farming into the open ocean where the temperatures are cooler and therefore you're not more exposed to the impacts of temperature changes, climate change. And also you've got the currents to be able to reduce the environmental impact that you see in more coastal waters.
And does this different system of farming the fish, I guess that's going to have impacts on what they are fed and how they are fed, is that right?
Absolutely. Transport costs of feed out to those open ocean pens is going to be significant economically and from a carbon footprint perspective. And so producing higher nutrient density feeds that can enable us to reduce the frequency of feeding is going to be critical for the sustainable viability of open ocean farming. So what we're trying to do in this aquafeeds program is make the nutrients themselves deliver the required physical attributes of the pellet, such as its integrity, its ability to sink at the rate at which the fish can feed them before it reaches the bottom of the cage, that it has the right water stability and doesn't break apart too quickly, but it forms a nice soft pellet quite quickly, which the fish will want to eat more of.
I guess it brings its own set of new challenges, I guess, in terms of the distance and the logistics involved in running them, I guess. This seems like a massive job in terms of basically starting up an entire industry to feed our growing sort of aquaculture industry. Is this something that multiple research institutes in New Zealand are involved in, or is it just a plant and food thing?
I think that all of the research institutes that do research fish growth and fish health are involved, but I do think that it needs a bigger collaborative effort. You've hit the nail on the head. It's a huge challenge, but it has huge potential wins for New Zealand, and it really needs a long-term commitment from government, the likes of the Cawthron Institute and NIWA and Plant and Food Research and the others who all bring unique perspectives and unique expertise to the huge problems we face in being able to build a sustainable aquaculture industry in New Zealand.
Because it's probably fair to say we're still sort of upskilling ourselves in this area because it is a relatively new industry, isn't it, aquaculture to New Zealand compared to dairy, for example?
Yeah, absolutely. We've only just in plant and food research started producing aquafeeds to test in the last year and a half. And it's a very complex process when you consider you have to not only meet the nutritional profiles of the fish, but produce it in a form that is palatable, that's stable, that can be fed out to fish pneumatically without breaking down, that can float or sink at the right rate, and that can be coated or what they call vacuum infused with oil that doesn't leach out into the ocean. The whole thing about leaching nutrients, you don't want to do that in terms of the organic loading in the environment that you're feeding them in. So there's a lot of technical challenges, and it needs a lot of collective brain power to solve those hurdles.
And internationally, are there countries which are kind of leading the charge on developing innovative aquafeeds?
Yeah, I think New Zealand is relatively late in the piece. There's a lot of countries looking at sustainable, more circular ways to produce aquafeeds. And I know that one firm, they've been able to reduce their aquafeed carbon footprint by 30% by dedicating their soybean meal to local soy meal only. And also they're already investigating the use of a grass protein concentrate in aquafeeds.
Yeah, I think I saw an interesting story about a Norwegian group that are looking at using microalgae, which is a way of, I guess, also fixing carbon dioxide and turning that into lipids and nutrients for the fish. Are we doing that here yet?
Yeah, that's not an area that I'm familiar with. I know people are doing it. I think Cawthron Institute, there's some involvement there, and it's probably a long-term perspective. It's a lot more challenging for New Zealand to tackle that because we're far closer to the forage protein growing industry than we are with algae, but it's a potential long-term area that we could leverage our expertise that we develop in this program through to in the future.
Yeah. Okay, assuming the funding fairy godmother could double or even triple investment in this area, it'd be interesting to know what your vision is for the next 50 years for the aquafeeds industry in New Zealand.
I would love to think that in 50 years, we have an aquaculture industry that rivals the dairy industry in terms of export revenue, that grows a number of fish species other than just our Chinook salmon. So I'd love to see that we were farming snapper and kingfish, and that we were feeding them on New Zealand-made aquafeeds made from New Zealand raw materials. I think the benefits of that vision would be just unthinkably big. You think about replenishing the oceans with wild fisheries, diversifying your land use so our soil quality is vastly improved, our land and air quality is improved. We've got total utilisation of all our horticultural and agricultural waste streams, whether directly into aquafeed ingredients or indirectly through insect biorefineries, we call them, with the generation of frass that can be used to help replenish the soil nutrients, and that we have thriving rural economies that are built on those open ocean farms, that we have pride in New Zealand exports that are made from New Zealand, not just made in New Zealand from imported ingredients, and that we can have pride in that our aquaculture is sustainable and something that can grow to help feed the world's population without putting undue pressure on the land-based resources.
That is a fantastic answer, Katrina. I'm pretty sure it's pretty hard to top that. So I think that's a really good way to round out this podcast. I think it's a brilliant vision, and I think it underlines the importance and the scope of this particular industry. So I'll stop carping on about things, and I'd like to officially thank you, Katrina, for schooling us in some of the science around producing aquafeeds. It's going to be fantastic to buy New Zealand farm fish reared on New Zealand farm foods that leaves the lightest footprint on our planet.
And thank you, Andrew. It's been a pleasure talking to you about something I'm really passionate about.
And thank you out there for listening. If you want to hear more of our podcasts, please check our Sigest podcast page or subscribe to our channel in iTunes or your favorite podcast provider. Mā te wā.